Welcome to G Fun Facts Online. Let's talk about cities and water. For most of modern history, the goal was simple: get water out. Rain hits the roof, flows into a gutter, down a pipe into a sewer, and is channeled away as quickly as possible. We built our concrete jungles to be hard, dry, and defended against the elements. But the climate is changing, and the rules of the game have changed with it. What used to be called a once-in-a-century flood is now a regular, terrifying headline. The old strategy of building higher walls and bigger pipes is proving to be a fragile and failing defense. So what's the alternative? What if, instead of fighting a losing battle against water, we started working with it? This is the revolutionary idea behind the future of urban engineering. We're talking about cities designed to act like giant sponges, buildings that literally float, and materials that can heal themselves. This isn't just about surviving the deluge, it's about designing for it. The future of our cities will be defined not by how well they resist water, but by how intelligently they coexist with it. So today, let's dive into the incredible innovations making our cities more resilient, more sustainable, and ultimately, more livable in a wetter world. At the heart of this transformation is a wonderfully simple concept: the sponge city. First popularized in China, the core principle is to treat rainwater not as a waste product to be disposed of, but as a precious resource to be managed. Imagine a city that, instead of shedding water like a raincoat, absorbs it like a natural forest floor. This is achieved through what engineers call blue-green infrastructure. Blue refers to water bodies like rivers and wetlands, while green covers everything from parks and rain gardens to green roofs and permeable pavements. Together, they create a living network woven into the urban fabric, mimicking the way nature has always handled water. One of the most fundamental changes is happening right under our feet. Traditional roads and sidewalks made of asphalt and concrete create vast, impermeable surfaces. When it rains heavily, this water has nowhere to go but sideways, creating flash floods that overwhelm drainage systems. The sponge city solution is permeable pavement. These surfaces, made from porous concrete or special interlocking pavers, look and feel like normal pavement, but they allow rainwater to seep directly through into the ground, recharging groundwater reserves instead of flooding streets. Studies have shown this single change can reduce surface runoff by an astonishing 50 to 93%. In Taiwan, one project found permeable roads cut the peak discharge of water by over 60%. Another key element is taking place on our rooftops. Green roofs, which are essentially gardens planted on top of buildings, are becoming increasingly popular. They absorb huge amounts of rainwater, reducing the strain on sewers. But the benefits don't stop there. They also provide natural insulation, cutting energy costs, they improve air quality by filtering pollutants, and they create new habitats for birds and insects in the heart of the city. Then you have rain gardens and bioswales. These are shallow, vegetated depressions you might see in a park or along a roadside. They are designed to capture runoff from streets and parking lots. The soil and plants act as a natural filter, cleaning pollutants from the water before it's slowly released or soaks into the ground. These blue-green systems are being put into practice all over the world. Shanghai, one of China's pilot sponge cities, has set a goal to have 80% of the city equipped with these functions by 2030. They've built massive sponge parks featuring wetlands and underground water purification systems. In Singapore, the Active, Beautiful, Clean Waters program is a masterclass in this philosophy. They took the Kallang River, which was once just a straight, ugly concrete canal, and de-channelized it. They transformed it into a beautiful, meandering river with lush, natural banks running through a public park. It's now a beloved community space, but its real genius is revealed during heavy rain, when the park itself becomes a natural floodplain, safely containing the overflow. And in Copenhagen, Denmark, a devastating cloudburst in 2011 led to a complete rethinking of their water management. Their cloudburst management plan integrates blue-green solutions across the city, creating special stormwater roads that can double as canals during a deluge, and designing public squares and parks that can temporarily become lakes to store massive volumes of water. It's a profound shift, moving away from single-function gray infrastructure to multifunctional landscapes that deliver environmental, social, and economic benefits all at once. While sponge cities manage water on a landscape scale, another incredible innovation is happening at the scale of a single building. This has led to the rise of amphibious and floating architecture, which allows buildings to coexist with rising water instead of being destroyed by it. Imagine a house that rests on the ground under normal conditions, but when floodwaters arrive, it simply floats up. This is amphibious architecture. The technology behind it is both simple and brilliant. The house is built on a buoyant foundation, which might be a hollow concrete base or blocks of expanded polystyrene. This foundation is connected to sturdy, vertical steel posts installed near the corners of the house. These posts don't hold the house up. They simply guide its movement, ensuring it floats straight up and doesn't drift away. All the utility lines, water, power, sewage, are connected via flexible, umbilical-like cords that can stretch as the building rises. When the flood recedes, the house settles gently back down onto its foundation. The key advantage is that it's a passive system. It doesn't require any human intervention or power to work. It just automatically adapts to the water level. This isn't just a concept, it's a reality. The Netherlands, a country with a long history of living with water, pioneered this approach in the town of Maasbommel, building 32 amphibious houses as part of their Room for the River program. A nonprofit called the Buoyant Foundation Project has been instrumental in developing low-cost, retrofittable amphibious foundations for existing homes in flood-prone communities, from Vietnam's Mekong Delta to historic towns in the United States. Distinct from this is floating architecture, where buildings are designed to be permanently in the water. In densely populated coastal cities where land is scarce and sea levels are a constant threat, this is becoming a serious solution. In Amsterdam, the Waterbuurt neighborhood is a stunning example, an entire community of floating homes moored in the water. Architects like Cohen Olthuis believe floating developments could revolutionize 21st century cities, just as the skyscraper did in the 20th. This shift in design is also driving a revolution in the materials we use to build. Traditional materials like wood and drywall are highly susceptible to water damage, leading to rot, mold, and costly repairs. To combat this, scientists are engineering a new generation of flood-resistant materials. One of the most exciting is self-healing concrete. Imagine a concrete wall gets a small crack during a flood. In normal concrete, water would seep in, rust the steel reinforcement, and compromise the entire structure. But self-healing concrete contains dormant bacteria or microcapsules of polymer resin. When a crack forms and water enters, it activates these agents. The bacteria produce limestone, and the polymer resin fills the gap, automatically sealing the crack from the inside. This can dramatically extend the lifespan of bridges, dams, and foundations in wet environments. We're also seeing advances in waterproof coatings made from advanced polymers that can be applied to walls and floors, creating a seamless, watertight barrier that can withstand immense water pressure. And nature itself is providing inspiration through biomimicry. Researchers are studying how organisms like the waterproof skinned gecko or the hydrodynamic shape of a swordfish survive in their environments. And they're translating these principles into new materials and structural designs. This physical evolution of our cities is being amplified by a digital one. The rise of artificial intelligence, the Internet of Things, and digital twins is revolutionizing our ability to predict, monitor, and manage floods. AI-powered models are now analyzing vast data sets, from satellite imagery and real-time weather data to topographical information, to forecast floods with unprecedented accuracy. Google's AI flood forecasting initiative, for example, now provides alerts up to 7 days in advance in over 80 countries, giving communities critical time to prepare. This data is fed by the Internet of Things, or IoT. This is a massive network of interconnected sensors deployed in rivers, drainage systems, and even in the soil, providing a constant, real-time stream of information on water levels, rainfall intensity, and blockages. But perhaps the most powerful tool is the digital twin. This is a complete, virtual representation of a physical city that is continuously updated with real-time data. Urban planners can use this virtual city to simulate any flood scenario they can imagine. What happens if we get a 100-year storm combined with a high tide? They can test the effectiveness of a new flood wall or a sponge park in the digital world to identify vulnerabilities and optimize designs before a single shovel hits the ground. During an actual emergency, a digital twin gives managers a godlike view of the situation, showing in real time which areas are flooded, which roads are impassable, and where to send help. It's about moving from reacting to disasters to proactively managing risk. The challenge of designing for the deluge is one of the defining issues of our time. But as we've seen, the solutions are as inspiring as the challenge is daunting. The path forward lies in this holistic, integrated approach that embraces the absorbent power of sponge cities, the clever innovation of amphibious architecture, the resilience of new materials, and the predictive intelligence of digital technologies. Of course, technology alone is not enough. This transformation requires supportive policies, updated building codes that encourage resilient design, and new ways to finance these large-scale investments. Most importantly, it requires community engagement and a fundamental shift in our mindset, from seeing water as an enemy to be conquered, to viewing it as a powerful, essential force to be respected and managed. The cities of the future will not be fortresses against the water. They will be dynamic, adaptive ecosystems that can thrive in a world of increasing uncertainty. By learning to design for the deluge, we are not just building better cities, we are building a better, more resilient future. Thanks for listening to Fun Facts Online.